Picture this. Humanity's intrepid explorers, the Voyager spacecraft, blasting through the cosmos only to smack into a blazing inferno at the very boundary of our solar system. A wall of fire scorching at temperatures between 30,000 and 50,000 Kelvin, or roughly 54,000 to 90,000 degrees Fahrenheit. It's a discovery that not only pushes the limits of our knowledge, but also ignites our imagination about what's out there beyond our cosmic backyard. But here's where it gets controversial. Is this really a solid wall? Or is it something far more fluid and mysterious? Stick around as we dive deeper into this interstellar adventure. Back in 1977, NASA unleashed the Voyager probes on a grand mission to chart the uncharted territories of our solar system's outer fringes and the vast interstellar void that lies beyond. These robotic pioneers were designed to push boundaries, and push they did, until they stumbled upon a searing phenomenon at the system's edge, registering those staggering temperatures as they pierced through. Now, before we go further, it's worth noting that the rest of this piece delves into the full details. But for now, let's unpack what we mean by the edge of the solar system. There are several ways to define it, depending on your perspective. For beginners, think of it as the point where the sun's influence starts to fade. One common marker is the end of the planets, like Neptune's orbit. Another is the Oort cloud, a distant spherical shell of icy objects that marks the outer limit of the sun's gravitational pull. Some of these objects can even loop back closer to the sun due to occasional gravitational tugs. But for our story, the key boundary is the heliopause, the edge of the sun's magnetic field where it clashes with the interstellar medium, the thin soup of gas, dust, and particles filling the space between stars. To make this clearer, let's break it down with a simple analogy. The sun emits a steady stream of charged particles known as the solar wind, which rushes outward, sweeping past all the planets and extending about 3 times farther than Pluto's distance. This creates a colossal bubble enveloping the sun and its planets, called the heliosphere. Imagine it as a protective shield keeping our solar neighborhood somewhat insulated from the harsher cosmic environment. The heliopause is the outer skin of this bubble, where the solar wind meets its match against the incoming interstellar wind, and their pressures balance out. As a result, the solar wind gets deflected, flowing backward along what's like the tail of the heliosphere. And this is the part most people miss. As the heliosphere cruises through interstellar space, it generates a bow shock, much like the wave a ship creates as it cuts through the ocean. This shock wave is a turbulent region where particles compress and heat up, adding to the drama at the boundary. In August 2012, Voyager 1 made history as the first spacecraft to breach the heliosphere and cross the heliopause, with Voyager 2 following suit in 2018. Before these crossings, scientists were guessing where exactly this boundary lay, but the fact that the two probes encountered it at varying distances from the sun backed up theories that the heliopause isn't fixed. It shifts like a lung expanding and contracting with the sun's changing activity, such as during solar flares or quieter periods. While it's not a rigid, impenetrable wall, despite the catchy nickname, both probes detected those extreme temperatures of 30,000 to 50,000 Kelvin in the region. Hence the wall of fire moniker, a vivid way to describe the intense energy there. Interestingly, the spacecraft emerged unscathed because, despite the highly energetic particles, the space is so sparsely populated that collisions are rare, preventing any significant heat buildup. It's like swimming through a vast, mostly empty pool where the water is hot but you're not immersed long enough to get burned. Even now, nearly 50 years after their launch, the Voyagers keep beaming back data from beyond this fiery frontier, standing as the only human-made objects to have made the leap. And they've uncovered some jaw-dropping surprises in our inaugural peek into true interstellar space. For instance, Voyager 2's instruments recently corroborated a puzzling finding from Voyager 1. The magnetic field just outside the heliopause runs parallel to the one inside the heliosphere. With only one probe's data, scientists couldn't confirm if this alignment was a fluke or the norm, but Voyager 2's readings prove it's consistent across the boundary, hinting at deeper connections between our solar bubble and the space beyond. This discovery sparks debate. Does this magnetic alignment suggest our solar system blends more seamlessly with the galaxy than we thought? Or is it a clue to unknown forces at play? Some experts argue it challenges our models of how magnetic fields behave at such scales, potentially rewriting textbooks on cosmic magnetism. But here's where it gets controversial. What if this wall isn't a true barrier but an illusion, a transitional zone where solar and interstellar influences intermingle? It could mean our solar system isn't as isolated as we imagine, raising questions about how far-reaching the sun's effects truly are. What are your thoughts on this cosmic revelation? Do you see the wall of fire as a thrilling frontier or a humbling reminder of how little we know? Is the magnetic field alignment a game-changer, or just another puzzle in the grand mystery of the universe? Share your opinions, agreements, or disagreements in the comments. Let's discuss.